company, Nick Lowther, in for Kai Hanley this morning. Froth flotation. Now, this sounds like something you'd pay money to do in the trade-off for younger-looking skin, maybe weight loss, or something that a celebrity is selling online. But it is all to do with energy and science. That's what we love. Siân Parkes is a chemical engineering PhD candidate at the University of Newcastle and works in the field of froth flotation. Siân, good morning.
Hi, Nick. It's great to be here.
Good to have you here too. You know what my first question is going to be, don't you? What is froth flotation?
So, froth flotation is a process that uses bubbles and special ingredients to separate the material that's valuable to us, like copper, from the material that's not so useful. So, say you had a big jar of jelly beans on your desk and I asked you to get only the red ones out. Instead of you having to go out and try and find them all yourself, I get to use these bubbles and special ingredients to do all the heavy lifting for me.
Okay, so jelly beans useful for me because I am a red jelly bean person, well spotted, but what's a practical day-to-day? Where would we see this the most in Australia?
Yeah, so it's happening all around the world and around Australia in different mineral processing sites, but it's not really something you're just going to walk down the street and bump into, but it is a really critical process. Minerals are critical to every aspect of our life, from your phone, which has over 40 different metals and minerals in it, to renewable energy, everything. Everything that comes together. So with this technology, are we seeing it mainly used in the mining sector, or is it other sectors we're probably not aware of? Yeah, it's mainly used in the mineral sector, but we are looking at using it in some other industries as well, like battery recycling. I was actually just in Germany working with a team over there looking at recycling lithium-ion batteries, but also we can look at using iron flotation for wastewater treatment as well. There's quite a few options. Yep, so it's in the back end as well, as you say, that recycling end and the tail end of, obviously we have the minerals work, that's all the work going in, but this can be used in the tail end. Fantastic. How long has this been around for? It's actually not a new process at all. It's been around for over 100 years, and it was actually first commercially used in Broken Hill in New South Wales. But it's recently now that we're seeing a huge amount of not just funding going into froth flotation, but a lot of innovation and research, which is why I'm so excited to be a part of it now. How did you get into it? Yeah, it's maybe not something you think about everyone being their dream, but I was really unsure of what I wanted to do when I finished high school, and so I started with a chemical engineering degree because I knew it would give me quite a broad range of opportunities. So I could have worked in pharmaceuticals, with food, even with brewing wine or beer. But one day I got an email from Professor Kevin Galvin offering me an opportunity to get some work experience in his lab, and I really loved how hands-on the work was, but also I could see that the work I was doing was directly helping industry solve the problems that they're having right now, which I think is quite rare. So, yeah, I've never looked back, really. Yeah, great. And how many years now for you? So this is my second year of my PhD, but I've been doing some work experience three and a half years now. Yeah, wonderful. Now, my favourite part of radio is when you try to explain something, and you brought a rock in to paint a bit of a picture. So tell me about a rock that you brought in, about the size of a fist, and I'll tell people what I'm looking at, then you'll explain how this comes together. So it looks like nearly glitter on the top there, various colours of greens and blues and purples. With those colours, what am I looking at? So this is a chalcopyrite ore, and that's the most common mineral for copper. So I crushed this down, put it in my reflux flotation cell, which was developed here at Newcastle, and I'm then able to recover all this chalcopyrite, which gets turned into your copper, which then gets turned into your phones, solar panels, renewable energy, everything. So the rock that we're looking at the moment, is this pre-froth flotation or post? Pre-froth flotation, yeah. I definitely have to crush it up a bit smaller, yeah. So what, to a fine dust? Or? Yeah, there's lots of different, depending on the mineral, there's lots of different ways you can do it. I'm particularly looking at those really fine particles because that's what industry is really struggling with, and there's a lot of valuable minerals in these really small particles that often get lost and end up in our waste streams instead. Is there an emerging technology out of this that is only really new, something where even you're wondering if this has some further possibilities? The technology I'm working on is called the reflux flotation cell, which has been around a little while now, but recently we're seeing it now being upscaled into industry. So just recently we had a delegation come from all over Europe and America to hear all about our technology, have lots of discussions about it, and look at getting these units, these really big units installed around the world to help save energy and water.
Can I ask, obviously, we're just using a standard water. Can that be reused, or is that so the water can just be continuously reused?
Yeah, that's definitely our aim, to reuse that water to prevent any waste. One of the aims of our Centre of Excellence that I'm working in is to completely halve the energy and the water requirements that we're using for this process. And these aren't small amounts. I'm talking about Olympic-sized swimming pool volumes of water. So it's sort of like if you were looking at buying a new dishwasher and I could say, here's a 5-star energy and water rated one. It's going to clean your dishes just as well, maybe better. And at the end, your water and energy bill is going to be halved. Why wouldn't you want that? So it's exactly what we're looking at.
Yeah, critically, this water that's, I think, the key question. Most people listening say, what actually happens to the water here? Because it's probably got a fair few nasties in it once it does the washing, or does it actually have a bit of a future, the water itself?
Yes, I am more focused on just optimising the technology in a lab, but they do reuse the water as much as possible. And actually, one of the things our centre is looking at is using green chemistry or biopolymers that are made from natural materials, and so if for whatever reason they do end up in the environment, there's no issues there.
We're talking to Siân Parkes, who's a PhD candidate in chemical engineering, about froth flotation today. How much longer for your PhD?
I'm hoping to submit my thesis at the end of the next year.
And what will this mean after that? Because you've done a lot of travel, haven't you?
Yes, yeah. That's one of the really cool things about chemical engineering. I've been able to study in Sweden and France. I worked on a project in East Timor just before COVID. And yeah, I just got back from Germany working on a really interesting battery recycling project there too.
Which country would you say is the furthest ahead with this technology?
I'd say Australia is definitely a front runner. We've got a lot of research and interest because of all the minerals processing that happens here, but a lot of other countries in Europe and across America as well are really starting to see how important this is because we're seeing such a huge demand for these minerals. Just taking copper as an example, it's been predicted that the amount we'll need in the next 20 years is more than we've ever used in the entire human history.
Yes. Unbelievable, isn't it? Yeah, and really for us to think about that, we talk about, and particularly the past few days, talk about the future of minerals and fossil fuels, but we have to remember minerals, as you say, so much more. Mobile phone, this very radio studio, you look at everything and you could probably pick more than I can of all these monitors and buttons and
Definitely.
say, you probably don't realise how much rock has gone into this studio, even this build. And the other part there you mentioned is you went to East Timor. For developing nations, what importance does that play for developing nations?
Yeah, look, we want to make sure that everyone around the world has a sustainable and also consistent access to all the technology, not just our phones and our TVs that we love, but that's really critical to our lives, like medical technologies. So making sure that there's fair access to that all around the world is really what we are focused on. And at the same time, making sure that no one's having all their energy and water used up as well.
Completely understand. So where for travels for you next, where will that take you?
I'm hoping to get back over to Germany next year to continue the project I've been working on. But really, I could go anywhere in the world with this degree in this area of research. So, yeah.
Okay.
Many opportunities.
Many. Now, it has taken you to a few countries. That might be a song that defines you, is my understanding.
Oh, yes.
What would be a song that might define you?
So I was thinking about this earlier. When I did an exchange in Sweden, we listened to a lot of ABBA. So, yeah, something like that definitely comes to mind.
We might jam some ABBA. How's that?
Sounds great.
Siân Parkes, thanks for joining us. Good luck with everything.
Thank you so much.
Looking forward to it. To find out some more, look up froth flotation. Very fascinating. Let us jam to some ABBA together on ABC Newcastle Mornings.